said maths is not fun? Well, I, Makwana Namraka, is here to show you that maths is just a fun challenge. It is as easy as y equals to mx plus c. And for those of you who didn't know, it is as easy as a straight line. So right now, it is the time for you to grab a paper, a pen, and a calculator and come learn maths with me.
Hey guys, welcome to another episode of Learn Maths with me on a hashtag Maths Tuesday. In today's episode of Learn Maths with me, we are doing laws of exponents. Exponents are used in order to express the number of times a number must be multiplied by itself. So in today's video, I will be showing you the laws that we apply when we are dealing with exponents. So I'll be taking the laws of exponents in a side paper where we will be tackling each law together, where I'll explain it and I'll show you how we apply it. So I have my paper of the laws of exponents we are tackling for today, and a side paper where I'll be explaining how you can apply the law of exponent. So please note that when we have something like 2 to the exponent, let me just say 3, this, when I say a base, I mean this number, which is 2. And when I say an exponent, I mean this number, which is 3. I really hope that you understand that. So what the definition of exponent is saying is that this exponent is used to tell us how many times this base must be multiplied by itself. So this exponent tells us that this 2 must be multiplied by itself 3 times. So this is what this law of exponent is saying. So I'll be explaining these laws of exponent and showing you like how we can apply them, showing you examples. So we'll be starting with law number 1. X to the exponent m multiplied by x to the exponent 2 equals to x m plus z. So as we can see, it is a multiplication sign in between these two terms. So let's hear what the explanation is saying. When multiplying like bases, remember a base is this one, a base is this one, this big one. When multiplying like bases, keep the base and add the exponents. So what they're saying is that when you are multiplying like bases, it means that the base of the same kind, we can see that we have the base of the same kind, which is x. So what they're saying is that when you are multiplying, this dot represents multiplication. When you are multiplying like bases, x and x, keep the base and add the exponents. So as you can see here, they are multiplying like bases, which is x. They have kept the base and added the exponents. So if you're having something like this, let me just write law 1. So if you are having the saying 2 to the exponent 3 multiplied by 2 to the exponent 4, you can see that, okay, you are having the same base, meaning that the law of exponent can apply. You keep the base and then you add the exponents. 2 to the exponent 7. Then you simplify your answer. I really hope that you understand this law of exponent. So let's move on to law number 2. As you can see, we are having x to the exponent m divided by x to the exponent z. They are saying it is equals to x m minus z. So let's go to the explanation. When dividing like bases, keep the base and subtract the exponents. So what they are saying is that when you're dividing like bases, as you can see, we have a division. We have a division line here, meaning that we are dividing. And what is happening again? We have like bases. So what they're saying is that when dividing like bases, x and an x in this case, keep the base and subtract the exponents. So they saw that they're dividing like bases, so they kept the base as the law is saying and minused the exponents. So if you're having, let me write law 2. if you're having, let me say, 3 to the exponent 5 divide by 3 to the exponent 2. So as you can see, you are dividing because of this division line, and then you have the same basis. So the law tells us that when we have the same basis, we keep the base and minus the exponents 2, which is equal to 3 to the exponent 3. And then you can simplify your answer, which will give you 27. So I really hope that you understand this law of exponent. Another way can be this way, where you have 8x to the exponent 3 over 4x to the exponent, let me say, to the exponent 2. So as you can see this, now you're dealing with numbers and variables at the same time. But do not be scared. We're just going to apply the law of exponent where it can be applied and divide the normal way we know where we can. So as you can see, these are not the same basis, but they can be changed into the same basis. You can 8 can be written in the base 2, and 4 can also be written in the base 2. So let's change. 8 can be written as 2 to the exponent 3, x to the exponent 3, and then 4 can be written as 2 to the exponent 2. Then you keep your x to the exponent 2, and then you simplify. Then you keep your base 2, and then you minus the exponents. As you can see, the variables are also the same basis, so you keep your base x and minus the exponents. Then you simplify. 3 minus 2, it's 1, and then x 3 minus 2, it's also 1. So another law of exponents is that when a base is raised to the exponent 1, it is itself. So if this 2 is raised to the exponent 1, it is the same as 2, and this x, as it is raised to the exponent 1, it is the same as x. So your answer is 2x. The other way, another person might have done it, might have said from this step 8x 8x to the exponent 3 divided by 4x to the exponent 2. Another person might have just said, might have just divided the numbers the normal way and then dealt with the exponent of the variable. So the person might have said 8 divided by 4, which is 2, and then the person saw that, okay, we are dividing like bases here. So the person kept the base and then minused the exponents, which is 2x to the exponent 1, and x to the exponent 1, it is the same as x. You can see that we have the same answers. So you can change them into the like basis, or you can just divide the numbers the normal way and then deal with the variables in an exponential using the law of exponents. So let's move on to law number 3. So what is law number 3 saying? As we can see that we have a term in bracket which is raised to another exponent. So this term in bracket has an exponent, and again this whole term is raised to the exponent z. So this law tells us that it is going to be equals to x m times z. So let's hear the explanation. When raising exponents to a power, keep the base and multiply the exponents. So as you can see that this term inside the bracket already has an exponent. So what the law is saying is that when you raise another exponent, so as they have raised another exponent on this term, they say that you keep the base and then you multiply the exponents. So they have kept the base and then they multiplied the exponents. Let me just explain it again. What they're saying is that when you're having a term inside the bracket which is already raised to an exponent, so as you are having a term inside the bracket and it is already raised to the exponent m, so they raise another exponent. If they raise another exponent on it, you multiply the exponents. You keep the base and you multiply the exponents. I really hope that you understand that. So let's just see how it applies, how it works. Law number 3. So let's say you're having in bracket a to the exponent 5, and then this term again is raised to another exponent, which is exponent, let's say 2. So what the law is telling us is that we are going to keep the base and then multiply the exponents. 5 multiplied by 2, which will be a to the exponent 10. Another way we can interpret this, we can make it more understandable, is by saying this. As you can see, this term, this whole a to the exponent 5 is raised to the exponent 2. So we said in the beginning, I said this exponent tells us how many times this term must be multiplied by itself. So this 2 tells us that a to the exponent 5 must multiply itself twice. So we're going to have a to the exponent 5 times a to the exponent 5. And the first law of exponents says that when multiplying like bases, keep the base and add the exponents. As you can see, we are multiplying like bases, so we're going to keep the base and add the exponents. So it's going to be equals to a to the exponent 10. So this law, you can, this, when you are dealing with something like this, you can apply this law 3, or you can interpret it in the way you can use law number 1. I really hope that you understand that. So let me just show you another example of law number 3. Let's say we are having 4 to the exponent 3 all to the exponent 3 again. So it's going, applying law number 3, it's going to be equals to 4 to the exponent 3 multiplied by 3. As you can see, this exponent is raised to another exponent. This term, which is already having an exponent, is raised to another exponent. So this law tells us that these two exponents must multiply. We keep the base and multiply the exponents, which is going to be equals to 4. 3 multiplied by 3 is 9. 4 to the exponent 9. So let's go to the last law, which we'll be dealing with for today. So this law number 4 tells us that when a base is raised to the exponent 0, it is equals to 1. So the explanation here says that any base raised to 0 is equals to 1. So as we can see here, x to the exponent 0 is equals to 1. So let's just see maybe 2 examples. We're having law number 4, law 4. So they're basically saying when we have something like maybe 5 to the exponent 0, this term is the same as 1. So 5 to the exponent 0 is equals to 1. So any number which is raised to the exponent 0 is equals to 1, no matter how big the number. So let me say you have 100 to the exponent 0. It is to the exponent 0, sorry. It is still equals to 1. Or let me say you are having a bracket, maybe 2x to the exponent 0. As you can see, this whole term is raised to the exponent 0. Not 2 alone is raised to the exponent 0. Not x alone is raised to the exponent 0. This whole term. Why am I saying so? Because it is in bracket and the 0 is raised to the whole bracket. So this 2x, this term will be equals to 1. I really hope that you understand that. Let's do another example. 4xz to the exponent z to the exponent 0. It is still equals to 1 because this whole term is to the exponent 0. I really hope that you understand the few laws of exponents that we dealt with today. I really hope that you stay tuned for a part 2 of laws of exponents next week. I'd like to say a shout out to my maths teacher, Mrs. Mawolo, who does quality check on each and every maths video I post, and to the maths handbook and study guide by Kevin Smith, which makes everything a lot more easier for me to explain.
If you enjoyed this video, please give it a thumbs up and tell me in the comment sections which topic you'd like me to cover. And remember, I do not promise to know everything, but I do promise to share and help where I can.